Hello students, welcome back to my channel EdTech Guruji. My name is Professor Aman Bhatia and I'm your digital guru. So we are doing this series Vigyan Ka Gyan, and we are going to begin with this topic of 11th standard, which is there in 11th state board, as well as it is equally important for your entrance examination, and physics without this topic is incomplete. Okay. So the name of the topic, as you see on your screen, is scalars and vectors. So today we will just discuss a little bit about what really vectors are. So without further delay, let us begin with the topic. Well, when we talk about scalars and vectors, before that, let us touch base with something we have already studied in the first topic, which is units and measurements and fundamental physics, that in physics, okay, we study a lot of quantities which are called as physical quantities. Okay, now what are physical quantities? Guys, physical quantities are those quantities which can be measured, okay, with the help of some tool. Like for example, if I say emotion, okay, if I say emotion, okay, any kind of emotion cannot be measured. It is abstract, okay, it is abstract. So I cannot say that emotion is a physical quantity. Okay, so what are physical quantities, students? Physical quantities are those quantities which can be measured, okay, which can be measured. So the most important term here which we need to understand, that what makes them physical quantity is that they can be measured. Okay, now let us see some of the physical quantities. Basically, physical quantities are divided into two parts. Okay, the first part known as fundamental physical quantities, and there are 7 fundamental physical quantities, which are time, length, mass, electric current, temperature, amount of substance, and luminous intensity. See, I'm just going through a very quick recap because we have studied about all this. Okay, so I'm just making it little more clear to you. So these are the 7 fundamental physical quantities. Fundamental means what? Fundamental means, student, that these quantities are not dependent on any other quantity or even each other. They are independent and they are complete in their own manner. So these 7 fundamental physical quantities have 7 fundamental units. Time is given in seconds, length in meters, mass in kilograms, electric current in ampere, temperature in Kelvin. So this is thermodynamic temperature. It is not degrees Celsius, it is Kelvin temperature. Amount of substance, mole, and luminous intensity is given in candela. Okay, apart from this, we have 2 supplementary physical quantities. Basically, the 2 supplementary physical quantities are the plane angle, okay, which is given as theta, and the solid angle, which is given as phi. We will talk about this also in the future topics. Now, rest of all the quantities which we will study in physics, let us say there are 200 to 250 odd physical quantities, except these 7 and 2 supplementary, rest all the quantities are called as derived physical quantities. Okay, now for example, the derived physical quantities are force, surface tension, work, velocity, acceleration, distance, displacement, speed, and many more. Okay, I cannot give all the examples here, as I said that there are many other physical quantities. Okay, but here are the few for just our understanding. Okay, so now we have understood that the 7 physical quantities, 2 supplementary, and the remaining all physical quantities which we will study in 11th and 12th are all derived physical quantities. Now, what is making all these quantities as physical quantities? Yes, the term measured. Okay, the term measured. Okay, these can be measured and the units are given for their respective measurements, guys. Okay, so when I measure a physical quantity, I have 3 important things to keep in mind. Okay, when I measure it, I measure a physical quantity with the help of magnitude, with the help of a unit, and the direction. Okay, so a physical quantity is measured basically with these three parameters: magnitude, unit, and direction. Magnitude and unit, okay, a lot of time they are taken together, okay, but there are some uh, quantities which do not have a unit, okay. So I will just keep it little separate for now, okay. Now magnitude and unit, okay. So magnitude here is basically giving me an idea about how much, that is, it is a number which is representing whether it is more or less in terms of number comparison. Unit is how I identify the quantity in physics, and direction, if at all it has a certain direction, I need to represent it. So let us move ahead. When I talk about certain physical quantities, okay, I realize that those physical quantities can completely be defined with the help of magnitude and unit only, okay. They do not really need any specific direction. It does not really matter whether they have a direction or not. Such physical quantities are called as scalar quantities. They are called as scalar quantities. So what are scalar quantities? Such quantities, okay, which have magnitude and unit, they are called as scalar quantities. Okay, now magnitude, in many textbooks you will find that magnitude means a number and unit, okay, but here I have still written it differently, magnitude separately and unit separately. But technically in a lot of textbooks you will find, okay, that magnitude itself means a number and a unit. So such physical quantities, okay, such physical quantities which have the magnitude only, magnitude matlab number and a unit, okay, such quantities in physics are called as scalar quantities. Okay, we have some examples here of those, like work, distance, speed, okay, all these are scalar quantities. Work, distance, speed, all these are scalar quantities. Okay, not necessary we are talking about fundamental or derived, that does not matter anymore for us. Now we are talking about the property of a physical quantity. So any physical quantity, whether it is a fundamental or it is a derived, it can be scalar if we can express that particular quantity in physics only with the help of magnitude, that is a number plus a unit. Okay, so such quantities are scalar quantities. Whereas there are certain quantities which along with magnitude and unit also requires direction. So along with magnitude they also require direction, and such physical quantities, dear students, referred to as vector quantities. Okay, so what are vector quantities? Such quantities which have magnitude as well as direction are called as vectors. Okay, so for example, okay, a very simple example, we have force. Okay, when you say apply a force, the first question comes, in which direction I have to apply force. If there is a door which is to be opened, the question comes to your mind whether it has to be pulled or whether it has to be pushed. This pull and push itself is nothing but a sense of direction. So automatically we realize that there are certain physical quantities which are incomplete if we do not give their direction. Okay, so the examples of vector quantities are force, velocity, acceleration, displacement, and many more quantities which we will study in physics are going to be in the category of vectors. Okay, very important concept, guys. You can't clear physics without good understanding of what really are vector quantities and how do we deal with them. Okay, so pay full attention here. Now, as I said, that these quantities also require a direction. So we cannot express them completely just by giving their magnitude. बॉल को अगर फेंकना है तो कौन से डायरेक्शन में फेंकना है ये बताना पड़ेगा. ओके, वेलोसिटी मीन्स speed in a particular direction. This we have also studied in 9 standard. Okay, displacement means a distance but in a particular direction. So I can say that we are little bit familiar about velocity, speed, distance and displacement from lower standards. So I hope that it is making sense to you that what exactly is a scalar and what exactly is a vector. Okay, now one thing we need to understand here: in physics sometimes we come across certain quantities, okay, which is not really a part of our portion, but we need to have a little bit of understanding here that some quantities we come across which have all these three things: magnitude, unit as well as a direction. Okay, like for example, if I say a very simple example, if I say about current, okay, if I talk about electric current is a fundamental physical quantity. Okay, now we know that current has magnitude as well as it has a direction. Okay, so whether it is a scalar or a vector, it has a magnitude, it has a unit ampere, it also has a direction. What is the direction? Current always flow from higher potential to lower potential. So plus से minus की तरफ जाती है. So is it a scalar or a vector? Now many students may refer electric current as a vector quantity. However, students, this is not correct. Electric current is not a vector quantity. Now, you may ask a question, sir, it has magnitude, it has unit, and it also has a direction. So, why it is not a vector quantity? See, if I say that there is this arrangement here of two wires, okay, and there is a 3 ampere current coming in this wire and another 3 ampere current is coming in the second wire, and they both have some angle between them. Okay, when these two wires come and meet at this particular point, what will be the current here? So you will quickly reply that, sir, we have studied in lower standard that here I will be equal to I1 plus I2, that is equal to 3 plus 3, that is equal to 6 amperes. If my next question to you will be that what if the angle between them is something else? The answer is, sir, still the total current in this wire will be equal to the sum of the magnitudes in these two wires. This is what we have studied. So now I can see that we have used normal algebra to calculate the total current in the wire. Okay, this is normal algebra. This is how we calculate scalars. So electric current has a magnitude, unit and direction, but it obeys normal algebra. Okay, whereas if I talk about another example, which is again very simple, you will be able to give that answer because you have studied it in 9th standard. Let us say we have a table, and on this table there is a block, okay, of mass m. Okay, there is a block of mass m and there is a force, okay, force of 10 newtons acting in this direction, and then there is a force of 10 newtons which is acting in the opposite direction. If I ask you that, students, what is the net force acting on this particular body? So you will quickly say, sir, we have studied that this type of a force which is equal in magnitude and opposite in direction, it is called as a balanced force, and hence the net force on the body will be zero. We have also studied that a balanced force does not result in moving a body or stopping a body. Newton has given very clearly in the laws of motion that only an unbalanced force can make a body move which is at rest and can stop a moving body. Balanced force is never responsible to change the state of motion or rest of a given body. So you automatically told me that, sir, the net force is zero because this type of force is called as a balanced force. But question, guys, here why we don't say that total force is 10 plus 10 is because this direction plays an important role. isn't it? That is why we said it is balanced, equal and opposite force. Opposite is nothing but giving the sense of direction, right? So this means that vectors do not obey normal algebra. Vectors do not obey normal algebra. So we will study this much in detail in our future lectures, that how do we add, subtract, multiply vectors, and this comes under the section called as vector algebra. That means along with having magnitude, unit and direction, a physical quantity must obey laws of, okay, they must obey laws of vector algebra. Then only that quantity can be given perfectly as a vector. Otherwise, as I said, like current, okay, like there is another example, okay, you will study something called as surface tension, okay. These quantities do have direction and magnitude both, but they are not vectors. So you will say, okay, sir, then are they scalars? I would say we may assume them to be scalars because they are adding like scalars. But in the real sense, in the real physics, these type of quantities come under a third category, which is called or termed as tensor quantities. So tensor quantities are those quantities which have magnitude, unit, direction, but they do not obey the laws of vector algebra. Okay, so such physical quantities are called as tensor quantities. We will not go much in detail in terms of tensor quantities. Okay, we will simply understand scalars and vectors because that is what is there in our portion, and that too vectors at length. Okay, now for now, we can assume that something which is not a vector is a scalar, but this term has to be in your mind, especially while dealing with MCQs. If it is written surface tension is, and the option A is scalar, B is vector, C is tensor, D is none of the above, then you have to choose it as a tensor quantity because the precise name is given, the category is given. However, if someone asks you, is surface tension a vector quantity, you can simply say no, it is not a vector quantity. If the option is given only scalar and vector, then I can choose that surface tension is a scalar because that suits best in these two options. Okay, so I hope this is clear to you. Okay, so we have understood an option. Example is surface tension. Okay, so now we have understood what are scalars, what are vectors, and what are tensor quantities. Okay, students, so I understand that you now are clear with the thought process of what are scalars, vectors, and tensor quantities. For further lectures, stay tuned to the channel, like the video if not already, subscribe the channel, hit the bell icon so that you get the notification as soon as I upload my next video. Also, share the channel with all the students in your connect. Signing off, take care, keep learning.